Hi, my name is Abhishek, and in this video, I'm going to discuss dynamic programming. Now, for those of you who are thinking what dynamic programming is a method for solving complex problems by breaking them into simpler subproblems. Some also refer to it as smart recursion or intelligent brute force. Well, dynamic programming is like building a wall brick by brick, where each brick is a subproblem and the complex problem is building the wall. Well, the cool thing about dynamic programming is that we do not repeat our subproblems. We memorize their results for later use. We'll see how this works later. Now, there are many ways to actually implement a dynamic problem solution. The most common one being recursion plus memorization approach, which is exactly what we are going to discuss in this video. The first step to write a dynamic problem solution is to find the subproblems. Finding subproblems is the most important part of any dynamic program solution. The next step is to write a recursive solution such that each call to the function complete one subproblem. And next we have the trickier part, memoization. Memoization is to store the results of each subproblem to be used later whenever the same subproblems occurs again. For example, let's say we want to calculate the nth Fibonacci number. For those of you who are unfamiliar with Fibonacci numbers, let Fn denote the nth Fibonacci number. Then, by definition, Fn is equal to Fn minus 1 plus Fn minus 2, and f of 1 is equal to f of 2 is equal to 1, which makes f of 3 equal to 2, f of 4 3, f of 5 5, and so on. Our task here is simple. Given an integer n, we have to calculate the nth Fibonacci number, or in our notation, f of n. Let's first work upon the subproblems. As we can see by the definition, to calculate f of n, we first need to find fn minus 1 and fn minus 2. Thus, one can say that to calculate the complex problem of solving fn, one first need to work upon the simpler subproblems of calculation of fn minus 1 and fn minus 2. The idea involved here is to chop down the complex problem of finding f of n into a summation of elementary problem, that is f of 1 and f of 2. Now let's start by writing our recursive function. So int f, int n, where n is our parameter. Now if n is less than 2, return 1, as we by definition we have f of 1 is equal to f of 2 is equal to 1, else return f of n minus 1 plus f of n minus 2. So this completes our recursive function. As you can see, it is by definition f of n is equals to fn minus 1 plus f n minus 2. Now let's take a look at the function call tree. Let's assume we have to find f of 6. So to find f of 6, we first need to find f of 5 and f of 4. In turn, to find f of 5, we need to find f4 and f3. We need to find f4, we need to find f3 and f2. Need to find f3, we go down to finding f2 and f1. So as we can see, all the branches of tree are ending with the terminal cases of f1 and f2. So we are building the complex problem of finding f of 6 from the elementary subproblem of f1 and f2. As it is evident from the tree that a function works alright, but we are totally forgetting the memorization part. If we look closely, we can see that we are calculating the same subproblems again and again. Now let's edit our recursive function to include memorization. First, we create a cache and initialize it with -1. -1 will indicate that we haven't found the nth Fibonacci number yet, and we are about to do just that. The terminal condition will remain same. However, if cache of n is not equal to -1, that is, we have already found this subproblem, then we just return its results from cache. Else, we store the value of this subproblem into the cache and then return it. Let's take a look at our function tree again. Now when our programs encounter the same subproblem again, it doesn't initiate any more function calls, which changes our solution from exponential to linear time complexity. So dynamic programming is real cool, right? But what if the subproblems weren't overlapping? Will this approach be efficient then? Well, if each subproblem is unique, then there will be no point in memoization. Memoization only works if we have the same subproblem again. If we do not have any overlapping subproblems, then there will be no point in memoization. Hence, this approach will not be efficient then. So those are the things we need to keep in mind before thinking about a dynamic programming approach to a particular problem. Thanks for watching. Bye.